Ladies and gentlemen, your lesson on spheres. Remember that a sphere is a round ball, basically. It's considered the set of points in space that are the same distance from a center point. You'll notice that your formula is very different from the formulas we've learned already about 3D figures. We are actually going to take the fraction 4/3, we're going to multiply by pi, and instead of r squared h like we use for the cone and the cylinder, we're actually going to use r cubed. Okay, so make sure you notice that difference. And this is only for spheres, because obviously a sphere really doesn't have a height. A sphere only has a radius. So when you look at your first example, as always, we write down our formula. V equals 4/3 pi r cubed. We have 4/3, we have our pi. Remember, those are just numbers that you're going to input on the calculator. But you do need to make sure that you're comfortable finding the radius in your diagram. Again, that's going to go from the center of the circular portion to the outside. So we definitely have a radius of 3. And I'll go over with you how to put these in. So we have to put in our fraction 4/3. We have to multiply by pi, which remember is over here. Remember to put in the 4/3, you want to use your ABC button. And then remember that we are multiplying by not just 11, we're multiplying by 11 to the 3rd power. So remember, you put the base in, you will come over here to the caret button, and the caret button, remember, allows you to raise any number to any power that you wish. So there's our 4/3 times pi times 11 cubed, and that's what it's going to look like on your calculator screen when you do all this button pushing. So since we entered the pi into our calculator, we have this messy decimal answer. And that's okay, because typically we're going to round this off, and we're approximating at 5,575.3 if we were to round to the nearest tenth. Okay, and these units are meters, so remember we're dealing with volume, so it's meters cubed. If you wanted to leave that in terms of pi, remember you can go and you can get rid of pi in your calculations, and we could have left it 1,774.6 repeating pi. That's another option. We'll squeeze that in here, because sometimes you are expected to leave your answer in terms of pi. So that's what it would look like if you left it without the pi in the calculation. Looking at your next example, we have to look at what we've been given inside the sphere. We have this segment that goes all the way through the circular part of the sphere. It continues to both sides through the center. So that tells us this is our diameter. If we want to find our radius, remember our radius only travels from the center to the outside, so it's going to be half of that diameter. Half of 28, remember, is a radius of 14. So we're going to put 14 in our formula, and we're going to make sure that we agree. Let's go ahead and do this in terms of pi first. So we're just going to type in 4/3 times our 14 to the 3rd power. And let's write that down in terms of pi first. So again, it's pretty messy, 3658.6 repeating pi. And then if we approximate by actually multiplying that by pi, we can see what the answer is without any pi in it. Okay, so this one is meters cubed, and if we want to round it to the nearest tenth again, we would say 11,494.0 meters cubed. So now that you know how to work with a sphere, being very careful that you use this formula, 4/3 pi r cubed, you're going to be working on some questions that are a little more challenging. So this side of your note sheet, you can see, invites us to work on a hemisphere. A hemisphere is literally just taking that sphere and chopping it down the middle. We probably learned about the northern hemisphere and the southern hemisphere in social studies class. So you'll see that I've got the formula on here for you. There's your formula for the full size sphere. We're going to cut it in half by multiplying by a half. So this is multiplication when you have a number outside your parentheses. We can actually type in 1/2 times the 4/3 times our pi. This one wants us to round to the nearest tenth, so we'll go ahead and actually use pi in there. But we do want to look carefully. I don't have any segments drawn on the diagram, so we'll have to read for that information. Here it is right here. They've given us a diameter of 15. So a diameter might look like this if we were to draw it. And we need a radius for our calculation for the volume of a sphere. So half of 15, remember, is going to give us this segment from here to here, which is a radius. So we're going to use 7.5. And again, this one wants us to round our answer off, so we're going to go ahead and type the whole thing in. There's our 1/2. There's our 4/3. There's pi. And then we'll go ahead and put in our 7.5 to the 3rd power. And we've got our 883.5729338. We round to the nearest tenth. We look next door and we realize we've got to round it up, 2.6. And again, this is an approximate answer because we've used pi. And we want to know approximately what it is to the nearest tenth. So we have it rounded. Now, the next question in your note sheet should look familiar. We did one similar to this the other day. We did a grain bin question. This is more of a traditional silo. And this traditional silo, as you can see, has got the cylindrical part, but then the roof of it, instead of being a cone like the question we did the other day, it is a hemisphere. So I've got it set up so that you have the formulas to use. We've got a half sphere. Remember, a half times the formula for a full-size sphere. And then I've got the formula for a cylinder. And again, this is something that we covered earlier in the week, but we're putting our two shapes together sometimes so we can work through this. So let's see, we've got a radius of 8 that they told us about, so we can go ahead and put that in. And as long as we're careful, we can put all this in. There's our 1/2 times our 4/3. I think we can leave this in terms of pi, so let's go ahead and just put in our 8 to the 3rd power next. And I got 341 1/3 pi. And then on this side, let's see, I've got pi, I've got my radius, and I've got the height of the, and I'm going to not put in pi because I just want it in terms of pi, so 8 squared times 50. I've got 3,200 pi. So remember, combined volume, I've got to add these two together, 341 1/3. Is 3,541, and remember, if you've got a repeating decimal, we're going to put the bar over top, and this is still in terms of pi, remember, because we have not pushed in the pi button. It gives you the total volume, remember, when you add the two pieces together. This last one is interesting because they want the remaining volume. So what we do with this one is we look at what two shapes we have. Remember, we've got a cylinder, so we're going to be using this formula again for the cylinder. And then, of course, we've got a full-size sphere. So your volume for a sphere, remember, is 4/3 pi r cubed. And it's a little tricky to understand what's going on. The diagram is not drawn to scale, so keep that in mind. They tell us the height of the cylinder is 6. And they tell us the radius of the cylinder is 3. But it doesn't look like it, even though it's supposed to be. The ball placed inside also has a radius of 3, so it's not drawn to scale for sure. So basically, we get to use the same value for our radiuses, and of course the height of the cylinder is the 6 that they gave us. So this time, think about it. What we've got to do is we've got to find the separate volumes, but then they said find the remaining volume of the space that's inside that cylinder. So I think this one is best if we leave it in terms of pi also. So we're going to take the 3 squared times 6, and we're going to see that that's 54 pi. That's the volume inside the empty cylinder. And then we've got the sphere, so we're going to put in our 4/3. We're not going to type in pi, remember, because we're doing this in terms of pi. And that tells us that the sphere inside that cylinder is going to take up this much space, 36 pi. So guys, instead of adding together the two volumes like we did in previous examples, we actually have to subtract these. So 54 minus 36 is going to give us the remaining volume of 18 pi left over, that's blank space inside the cylinder. So, tape these in your notebook. You've got a packet to work on, and you should be pretty comfortable now that you know all about spheres, hemispheres, and composite figures.